Okay, another story here. When I was in university, special triangles, we're going to show you how to do calculations of trig stuff in your head. That's what we'll show you. Okay, show you how to do things without using a calculator. I always threaten not to let you use a calculator on your next test. I always bail, but I'll make the threat again that it's possible that you should be able to do some of these calculations in your head. When I was going off to teachers college, I had to take what's called the GRE, which is like the SAT, but going into your master's. Okay, so when I get to my master's, so I got a perfect course on the math. But the reason was they gave a question that was calculate sine of 30 or something like that. And I thought, oh, geez, how do you do that? And what I did was I remember back to high school, what we're doing here right now, to find the exact values of these things that I use the calculator. So the first one's going to be, the first proof will be, and you will be asked to recite this proof. There'll be two that we're going to do today. One you will be asked to regurgitate on your next test. The second one you'll have to regurgitate on your final exam. And the reason I'm making you do this because this is fundamentally a horribly important skill for grade 11, grade 12, and university math here. So I'm going to do the proof of the 45-45-90 triangle. Can anyone think in their mind how I can get a 45-degree angle from? Yes.
90-degree triangle in half.
Cut a 90-degree angle. I got a 90-degree triangle in half, a 90-degree angle in half. So what I'm going to do is I'm going to start with a square. And I'm going to chop it in half. Okay, a square, if you notice, has all four sides the same. It also has all four angles the same. The reason I want to use a square rather than a rectangle is because when you cut from diagonal to diagonal, it's going to chop the angle right in half, okay? So I'm going to do something like this. And I'm going to get a beautiful angle, a beautiful triangle, looks something like this. That is beautiful. There's 45 degrees and there's that. Okay, what is the simplest triangle that's going to have the two sides to be the same? What would be a nice number I could choose? 14, well, it looks like a nice number I could choose. I'm going to choose 1, okay, because 1 is a nice small number. So I'm going to start with all four of these sides being 1. It's going to make those sides 1. And I'm going to solve for x. Without using your calculator, how would I solve for x? Square root of 2, how'd you get that?
8.
Right, so we're going to use Pythagorean theorem, right? So I'm going to say x squared equals 1 squared plus 1 squared. So x squared equals 1 plus 1. X squared equals 2. X equals root 2. So what I've just created is a 45-45-90 triangle. So any angle that, and we're going to talk about proportions today for that. I've just proved then the 45-45-90 triangle. I want to show you why this is useful in a sec. So when we did this, we took a square and chopped it in half. We got our 45-degree angles. So I'm going to start to pick people that haven't raised their hand today. To start off to tell me what the sine of 45 is. Now do not press on your calculator because we're going to avoid it with your calculator. Anytime you give me a decimal for this answer, you will be marked wrong. Okay, we're going to use the exact value. And I have a kid in my morning class that I always pick on. Tells me he wants to be a doctor, and I say, if you round and you're my doctor, instead of, getting my heart opened up the right spot, you're going to miss. Get my lungs, so don't do that, okay? So, can someone please use SOHCAHTOA? How do I find sine 45? What does sine equal again?
Did you do inverse?
No, we don't remember that. What's sine equal again? Awesome, thank you very much, okay? So for this triangle, thanks for playing along. For this triangle, if that's 45, what's the opposite? What's the adjacent? What's the hypotenuse, please? What's the opposite? What's the adjacent? What's the hypotenuse? Opposite. Here's your adjacent. Here's your hypotenuse. Okay, so sine 45. Summer and Liam, can you tell me please what sine 45 equals? Go ahead. 1 over square root 2. So the way I'll word this on your test, I will say, prove that sine 45 equals 1 over root 2. And what you will do is you'll reproduce that beautiful triangle, something like that. Can someone do the same thing with cos? Maybe Emily in the back, since you've been so nice and quiet this entire year. What's cos for? What does cos equal, please? Okay. What does that equal then? 1 over square root 2. And it sort of makes sense. If the sides are the same, then again, the opposite's going to work out nicely. Can I get third brave soul do the same thing for tan 45? Observer Jason, good. Okay, so I can very easily say to you, prove on your test, prove that tan 45 equals 1. And you just reproduce all that and not do that. Wow. Now again, it makes sense as far as that, 'cause if you think of opposite and adjacent, the tan is going to be the ratio of your slope. It's going to be the amount up versus the amount across. 45 degrees is a perfect angle, so it should work out nicely like that. Are there any questions on this before we move on to the next one? It is, you're starting to get a 45-degree angle, you start with the square, chop it in half, and then you're just using SOHCAHTOA after that. You guys are far too polite, because this is deep stuff that we're doing here. No, this is deep. This is like weird. We're into weird stuff. All right. Oh, sorry. Go ahead. You will get 0.70714. Oh, you have a super duper calc. What do they have? Root 2 over 2?
Yeah.
Okay. So what they just did, we talked about rationalizing. And it is super duper calc. So that'll work too. So what they did is they rationalized. Remember, to get rid of a square in the denominator, you multiply the same thing. So it's going to be root 2 over 2. And that works the same way. Okay. Oh, you guys are super duper calculators? Oh, that's not right. Yes.
What if the numbers are
Yeah, well, we'll talk about that in a second. It would work the same if it was like 2 and 2, 10 and 10, x and x. They have to be the same proportion though. Like, so it'd be, and we'll talk about that in a sec, but let's say it's like 10 and 10, it would be 10 root 2. Because it would be like 10 times bigger, right? But we'll deal with those questions in a minute. We'll start with this, but good question. I don't know, I'm glad you asked. That's our next one. Next one's going to be the proof of the 30, 60, 90 triangle. Okay. Now, Alex, I don't want you to shout out this time. Hold it in for 1 sec, okay? How do I get in life? How can you force something to be a 60-degree angle? How can you force something to be 60 degrees in life? Don't shout it out. Nope, that's too difficult for me to count 92 grades. Has you ever seen a 60-degree angle in real life? I guarantee you all have. Alex, do you want to jump in there? Or do you still not know? Okay. No problem. Okay, you're going to start with a. It's not a name now. Oh no. Equilateral triangles. Can somebody tell me what an equilateral triangle is, please? Everything's the same. All sides are the same and all angles are the same. Okay, so if you look at an equilateral triangle, it's going to be dot, 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 and 60, 60, 60. Where did I get 60, 60, 60 from? It all has to be 180 divided by 3. Okay, so it works like that. And you're exactly right there. I'm going to go right down the middle, like this. And that's going to give me a beautiful triangle. It looks like this. Okay, well, Liam, play along for a sec. What's that top angle going to be? How'd you get that? Good. And that also, take a look, is going to be written as a right angle. Now, I'm going to give you a second to scribble down because there's an aha moment still has to come. Back to the triangle on the left. What length are we going to want to use for each side? Sorry? Oh. I heard somebody say 1, and I said, yeah, you could, but why would you want to use 2, Chris, do you think? Awesome. I'm going to use 2 for each of them, because when you cut that in half, then that's going to be 1. Okay, so you see what I did there, right? So 2 for the hypotenuse, 1's going to be on the bottom. I'm going to call this guy x again. Can somebody tell me without using a calculator how I'd solve for x? Yeah, go ahead. Oh, whoa, no. Sorry, let me rephrase here. I'm sorry, I didn't correct. What's the way I can solve for x? It's got to be for area, it'd be all that sort of stuff. Right? Diagonal theorem working beautifully again here, okay? So we're going to say x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4, x squared equals 3, x equals 3. And this is, remember, on Friday I was talking about root 3 and all that stuff, right? And that's just the reason it wasn't beautiful. So when I draw my triangle, I'll draw a beautiful triangle here that goes. You have root 3, 2, 1, right angle. There's a 30, there's a 60. Okay, you can get tons of information from this. Using this triangle, someone be brave and tell me what sine 30 is and then how they got it. Go ahead. Now, how'd you get that? Yes, but close, okay? That's going to be sine 60. Right, because depending on what angle you're using for the opposite, okay? So what's sine 30 going to be? No? 1 over 2, 1 over 2. Because your hypotenuse here is always going to be 2. So this is the, we got that because we're using this stuff a lot. So 30 is your key angle here. So opposite's going to be 1, hypotenuse is going to be 2. Can someone do the same thing for 60? Okay, so for 30 degrees here, right, opposite go right across, so 1 over here. If you're using 60. Sorry? Why? Just because their two angles are 30 and 60, right? So, all right, how do I get cos 30? What's cos 30 going to be? Yeah, go ahead, Alex.
It's going to be root 3 over 2.
Oh, does that blow your mind? Sine 60 and cos 30 are the same? Weird. We'll deal with that when we get to graphing and everything else. Okay, what's cos of 60 going to be? What's cos of 60 going to be? 1 over 2, okay? It's going to be opposite. And the reason that is, right, if you think about it, it's going to go one way. Here's your 60, there's your adjacent over hypotenuse, so on that. All right, finally, tan of 30 and tan of 60. Tan of 30. 1 over 3. And tan of 60 equals root 3 over 1. Now, the reason where all those things came from, were again, we're just using opposite adjacent hypotenuse from those triangles. So, what will be relatively important for you guys is not to memorize those triangles. Some people here are going to say, hey, my name is Liam and I love memorizing. Okay, so what Liam would do is he would take his photographic memory and take a mental picture of those two triangles and lock them in for the long term. Where I'm coming back to my original story for me as a master's student, okay, what I did was I thought to myself, yeah, I remember these. Okay, take a equilateral triangle, chop it in half, you get your angle. Over here, take a square, chop it in half, you get 45 degrees. Okay, so that's how I do it. Even to myself, I don't have that memorized. If I were to close my eyes and you were to say to me, I know what the numbers are because I know what sine 30 is, you just did it. But if you were to say to me, draw that triangle, I always get confused what goes where. But if I start with the equilateral, then of course I can get it right away. Okay, so again, it's a proof, but I mean it's not really that bad of a proof because you want to do it every day. Okay, can everyone close their eyes for a sec? Okay, Liam, question, then you can close your eyes. Liam, question.
So whenever you have a 30-degree angle, the sine is always, sine 30 is always going to be, one side is going to be twice as big as the other,
Right.
always?
Yes, always. Always. That's the portion rules. Okay, everyone close your eyes for a sec. Brad, you too. Who's horribly confused? Raise your hand. Who feels fairly good about what's happening today? Okay, who thinks with a little study they could get full marks on this on their test? Okay, half the class. You guys all can. Okay, I'm going to pause this video, then we're going to apply this.